Hi, my name is Mike Hartington. I'm a developer advocate at a company called Ionic, and I want to talk about abstractions today. Now, typically, when people talk about abstractions, they normally mean this first kind, where we have a low-level concept, whether it's an API or a language itself, and working with it can be either cumbersome or lead to a lot of potential errors in the form of user error or code that is very fragile and easy to break. Now, to make working with this language or this API a lot simpler, what developers have often done is just build something on top of it that allows you to safely work within that runtime or within that language and be a little bit more productive. We're not necessarily creating a whole new language or a whole new library. We're just adding some helper functions. We can kind of think of this like a utilities concept. Now, while most people find this very helpful, some people decide that this isn't enough. They want more, and so they build another abstraction on top of that. This one including more features, more safety, perhaps new concepts that are abstracting away the lower level concepts, and then so on, so forth. We have this whole entire concept of a hierarchy where there's an abstraction that is n degrees removed from the lower level, whether it's 1 degree above, 2 degrees, or even 5. Now, with abstractions, there also comes some trade-off. We also have to think about the impact on overall size. The further abstract you are from a given target, chances are you are also going to increase the final code output. You could be including more functions and more code into that into your project by using the wrong abstraction and bloat your project up pretty quickly. Something also worth considering is whether or not the abstraction also gives you an escape hatch. Now, languages like Python and Lua are built on top of C. They abstract away a lot of the inner workings that C offers, but also give you an exit hook so that way if you need to drop down to C, you can do that. You can think of other libraries out there on the web that also offer a similar escape hatch. They may build on top of something like Canvas and abstract away a lot of the complexity that Canvas has, but if you need to, for performance reasons, you can just you can just kind of hop out of that and get into the native layer of Canvas. Now, these are the traditional kinds of abstractions that I think most people are familiar with. Abstractions also operate on another vector. They can also be thought of as a spectrum. And this is something that once you realize how this relates to the code you work with, you'll see that you've dealt with this more often than you think of. When we think about spectrum abstractions, you can think about the code that you write and where's that code going to run. The traditional example of is this code going to run in Node or in the browser can now be updated to is this code going to run in Node, the browser, or runtimes like Dino. All of these have different trade-offs, and when we think about code that runs in Node or code that runs in Dino, they are on opposite ends of the spectrum. They are so different from one another that without having to work real hard to make sure that code, without having to work real hard and set up complex build systems, code may not be able to run on one or the other. Where if you have code that can run in Dino, chances are you can figure out a way to get it to run in the browser. And if you have code that runs in Node, you can figure out a way to get it to run in the browser as well. These are the kind of spectrums that we deal with. The one that I'm more familiar with is the idea of being able to do cross-platform development, whether or not your code can run in the browser, but also on this native device. Now, if you start off at the web side, you're going to be able to get that code running onto the native device, but Oftentimes, you might run into issues where features don't exist on native or in a native context due to limitations on a web view or to just not having the APIs available in general. On the other hand, if you start off in the native side, now have to go through a lot of work to get that code that runs well on the native device to work on the web. Doesn't always work out the same way. It's much easier to go from the web to native than to go from native to the web, in my opinion. This type of spectrum of cross-platform development is something that we deal with a lot at Ionic, and it's something that really drives us forward. Being able to have that nice sweet spot of I can write my code that knows how to run on the web and how to run on native very well. It's something that drives us and pushes us forward. So as you start to write your code and start to create new projects and pick your libraries and pick the tools that are going to work best for you, ask yourself, is this code going to be able to run on the various platforms that I want to support? It could be JavaScript in the browser one day, or it could be JavaScript in your terminal via Node or Dino. It could be your native device, or it could be a new set of devices that haven't even been invented yet. Keep the abstraction of not only how much of a code footprint does this abstraction offer, but where does this code run and how much work am I going to need to put in to get it to run on that platform in mind. With that, thank you.